G'day, good evening. I hope you're well where you sit or stand and listen. Today's got a bit of a theme to the show. It's on International Compost Awareness Week. So it's going to be all a bit of a theme for once, so it'll be nice. And just for those who are unaware of what this channel's about, it's about cannabis, medicinal cannabis, and it's to do with legal activities. I promote the law, respect the law, and to do with the growing too. It's all organic practices. So that's why it's a good theme for today with the International Compost Awareness Week. So even though I have talked about compost and the cation exchange and those mulching of late, but we can always refresh. It's always good to know these things and see how it goes. I hope there'll be some questions in there. I'll put a little question and answer thing in the chat up the top, that if you click it, it's usually live chat or top chat, and there's a questions thing there, or I filled it out and I just said, what would you like next week's show to be? So what to be on or what to theme and all stuff like that. So if there's any suggestions, please put them in. And I'm going to start with the compost. It's all sorts of stuff to do with healthy organic compost. I'm just going to get to the share bit. Invite, nope, share. Rightio. I thought this was pretty cool. Recycle your organics. So it's just to do with the big plant, and it just shows the big rhizosphere here around all of the biology around the roots. Feed your soil, because yes, that's what the plants are doing. They're eating. So we've got to feed your soil. And down here it says the soil connects us all with humans, but all life on earth. Through plants and their roots, air it breathed and exhaled, water that seeps into the soil from rain and snow, and the organic matter that is returned to the soil. Living connections are made and sustained. 25% of the world's species live in the soil, this says. They clean out water, feed the plants that feed us, and calm our climate. How cool is that? Yes, and on the right-hand side is for all the Quebec people. It's in French. In l'actualité. But yeah, it's pretty cool. All about how the cycles. What you put in, what you get out. I thought this is pretty good too. It's a nice International Compost Awareness Week with a title for healthy soil and healthy food. Remember last week, so I was talking about the antioxidant level and the catechins and the benefits of growing organics to conventional. So it sort of backs up this compost as well. Yep, I'm sharing, good. All right, I'll stop sharing. Right, hello, add to stream. Yep, there we go. Got a title for it. Yes, hello, Nene. Cheers to you too. I'm going to start sharing more on the compost. So share screen. Let's see what I can drum up. There's quite a few slides here because it's all to do with nutrient cycling compost. And nutrient cycling can be assessed by measuring a few indicators. There's a fertility indicator, an organic matter indicator, and a soil reaction indicator. And the fertility indicators, they include mineral nitrogen, mineralized nitrogen, soil nitrate, soil phosphorus, potassium, sulfur, magnesium, and quite a few more, and soil salinity. So that's what you're meant to measure for fertility indicators. And then for organic matter indicators, you'll want to do your carbon to nitrogen ratio, the decomposition, microbial biomass of the carbon, the particulate organic matter, soil enzymes, small organic matter, and the total organic carbon and total organic matter, because that's how you get the CN ratios. By knowing a few of these things in here, you can work it back. Like if you, anyway, the soil reaction indicator is another one that's measured by soil pH. So if you can get good compost happening, you can get all of this nutrient cycling as the way it should, and all of these tests will be good. And the gains of nutrients to the soil, there's different ways that the soil can gain its nutrients. So with your composting, that's one of the best ways, because it's just got bulk immobilized and some natural chemicals that are available to the plants too. They're not all immobilized, they are mineralized. And the gains of nutrients to the soil, there's a few of them. There's atmospheric deposition, and that refers to nutrients that are deposited on the land or the water from the air. And then the biological fixation, and that's conservation of biological and available atmospheric nutrients from plants' available form. And application of synthetic or chemical fertilizers, when they're applied to agricultural soils, they increase yields and quantity, but generally there's a downside effect to that. So I don't promote those types of ways. And another way to gain nutrients into the soil is farmyard manures and other manures. They are brilliant. They're a byproduct of livestock production and an excellent source of nutrients for crop production, because they've got a lot of microbes in there. And the ones that aren't active, they'll just lay dormant, because, you know, inside of a prokaryotic cell of a bacteria, the one at the end is a little round ball thing. It forms a endosperm. So when it dies off, it can reproduce in its favorable conditions. So that's the benefits that you get out of the manures. And another thing is your green manures, or your plant residues. And that's, yeah, that helps a lot too. Helps a lot too. And there's ways that can be removed from the soil too. That's one thing you've got to watch for. Not very good. Crop uptake and removal of nutrients from the soil used by plants are taken up by soluble inorganic free iron forms from soil solution and are removed from soil in harvested materials that leave the field. And then another way to remove nutrients from the soil is from runoff. So loss of dissolved nutrients in water moving across the soil surfaces. So mulch can eliminate that one, number 2. Another way for erosion, removal of nutrients from soil is erosion, which is by wind and water. Leaching, when things are dissolved and they move through the soil, through the groundwaters and over surface water. And gaseous losses to the atmosphere is another removal of nutrients from the soil when they change forms from a solid to a liquid or to a gas. And nutrient cycling, removal of nutrients. So this is like a cool little chart that shows how it's in action. So how the nutrients come in, and they're cycled by settling, and they start to decompose, go into the litter, and then plants can reuptake them. So that's how they'll cycle back through in this example over here. And a nutrient and an atmospheric example is when they come in through nitrogen fixation, they'll come in through there, and then they'll get utilised and uptaken through the plants through that way. Then they can go, different microbes will denitrify it and put it back into the release, back into the atmosphere. Nutrient cycling, in addition to the variety of inputs and outputs, plant nutrients exist in many different forms of nutrient pools within the soil. And those the different pools to make up soil solution, you've got organic matter, soil organisms, soil minerals or chemicals, soil adsorption with a D, and then your cation exchange. They're cycling. And nutrient cycling, removal of nutrients from the soil. This is just a little a flow chart just showing how rainfall comes in and it can reduce through surface runoff and cycle things out. So if things have an anion with a negative charge, it might be like a nitrate, for instance, an NO3 minus. that'll just come in, jump on with the rain, easily flow out because it won't attach to anything in here. Littering, removal of which, littering, that adds to the pool. All right, also it's a removal. And then things from the litter, they decompose through saprophytic type of biology and ends up in the soil. And the soil can leach it out, and weather comes back in from the rock and plants uptake it. Nutrient cycling, removal of nutrients from soil. Okay. How soils retain nutrients. Well, that's from holding on to it through the cation exchange. So through electrical charges in the soil. So you've got to create the substrates to hold on, to have the elements that you want, and you want them to be bound to things so they're not leached out. And through that way is through the cation exchange capacity. Explained that a few talks ago into the detail about that. And this is just briefly how it exchanges. So if you've got clay over here, which is a great isomorphic substitution and a particle exchanger of the chemical elements, mineral elements, and here's the hairs, roots of the hairs of the plant. So it's just, they put out organic acids like the protons, H pluses, and then that will be sitting there, and then there will be a room for an exchange to happen because the clay will have an element and it'll swap with that one, and that's how that exchanges, the little cycle. How they retain it. No, that's in the CEC. Exchangeable, how they exchange. Mechanisms of nutrient uptake are absorbed by roots as ions from the soil, water, or solution. They can also be absorbed in minute forms through the foliage, so through foliar sprays. And that's a good way that I promote probably using chemicals, and that's because you can get exactly what you want, what element is deficient, and then you can make it up in 100 ppm solution and give it to the leaves when it's not in veg, when it's not in bloom, and you can get a really good result from that. So the mechanisms of nutrient uptake, diffusion. So there's two ways. Yeah, anyway, I'm just going to, diffusion. It's the movement of ions from a zone of high concentration to a lower concentration. It's like when you sort of, anyway, short distances, immobile nutrients. Importance from nutrients such as phosphorus and potassium that are strongly retained in the soil are present at very low concentrations in the soil. Yeah, actually, phosphorus, sorry, that's, you get that from the DNA of biology. So that's helps with the compost. If you've got a lot of, and that's what the composting is, the breaking down of all the different materials, and you end up with all the DNA because it was living, and you get a high amount of phosphorus in there. And they say that if you do a run through a crop, you'll only have used, there'll still be 45% available phosphorus that's still immobilized, left over for the second one to run. Diffusion, the nutrients will diffuse. Actually, that's pretty, I'm not going to get into that detailed. Yes, mass flow is the other way of watering or ion exchange in the plants. And the mass flow is just when it pushes through fast. Good way to describe the mass flow is you just tip it in the top and it just forces all the gases and everything else out through the bottom, but it has a high chance that it's going to leach things too. And there's a way that you can add elements into plant uptakes by different processes. To describe mass flow and diffusion is diffusion's a good way where it might be a plant will be sitting there and then water will slowly come up through like an ebb and flow system in hydroponics, and it'll just slowly absorb in through the plant that way. This way pushes the gases out a lot faster, mass flow. But it's talking, the whole reason of this is the mechanisms of nutrient uptake. The root interception. Roots grow to the nutrients. Yes. If you've got, like you'll see for drip irrigation, their availability is just in a circle where you drip it, and that's where you'll find the root hairs if you were to do a side cut off. This type of uptake is not very efficient because roots have direct contact with less than 1% of the soil. That's why it's good to recycle soil. Very, very good. This is that way of getting different elements into your plant by different techniques. So if you want to get into phosphorus, you might think, oh, I'll do a diffusion technique because it's more efficient at getting the phosphorus up. Actually, I should see if there's any questions, I suppose. Hello. Good morning, Renee. Good morning, Ned Kelly. How are you? Purple Green. My mates, how you going? Friends, I'm just checking back to see if there's any questions and stuff like that. Today, it was talking about this stuff. It's International Compost Awareness Week. Ooh. But back to the slides. Share screen. Entire screen. Right, I was up to, that's right, the feeding of not cycling, nutrient cycling. Nutrient uptake by plants. This all relates to compost. Because I've been so heavily through compost of late, I'll get to a little bit into compost, but first we've got to see how the nutrients cycle so you can understand what happens in the composting process when things break down. The whole reason you want things to break down is to be immobilized and held up in different forms. So if different bacteria and fungi and other microfauna and flora, they break things down and it'll be immobilized inside things. So as soon as the plant wants it, bacteria will go, all right, there's some phosphorus. We'll try and attract some phosphorus solubilizing bacteria, and then that will solubilize some of that bound phosphorus that's into minerals, and it'll break it down, making it available for the plants. So that's the whole compost cycling thing. Back to this. Nutrient ions, they must be dissolved in soil water solutions for uptake by plants. They can't be chunky. They move from soil solution to the vascular center of the plant root, passing through at least one cell membrane, the skins that hold the cells on the inside. Apoplasts and symplastic pathways, they flow to the vascular bundle inside of the plants. And the movement across the membrane is either a passive or an active uptake. I'm not going to go into that. It's a bit detailed when you're passing through cell walls to try and pass energy, how plants move and get their nutrients internal. I'm just briefly touching on it. Cation exchange. All right. Mass flow and diffusion, might be back to it, because mass flow and diffusion occurs simultaneously to supply nutrients to roots and cannot be treated as separate processes. Well, it can be. You can have a mass flow. You can just pour it in fast, or you can slowly diffuse it. Anyway, some of these things, they are related to the concentration of solutions in the distance from the root surface to the absorption time. Okay, next, the maths. I'm not going to go through some maths. The mechanisms of nutrient uptake. That was the ways to, the two different main ways that you can get nutrients in the soil, from mineralization and immobilization. And the mineralization is when the microbes, they'll convert it into nutrients or minerals. So it'll be held up into something and then they'll break it down, so it's going to break down. And from the organic forms to the inorganic forms. It's mineralization and immobilization. I'm sure it'll say it. Mineralization increases the bioavailability of nutrients that were in the decomposing organic compounds, mostly because of their quantities, nitrogen, phosphorus, and sulfur. We get into the compost stage. And immobilization, it's the opposite of mineralization. It's where they're immobilized. So you've got elements that are held up and bound in plant tissues, in different types of sticks and leaves and things like that, that are sitting there that haven't got an atom nitrogen or phosphorus mineral sitting there. It's bound up, and that's the way you really want it. That's what compost is. There's a hang of a lot of immobilization going on there. So it's just ready to be unlocked by soil microbes to feed the plant. So the transformation, that's how it cycles through. This is a nice little chart of the cycling of the nutrients. There's different processes and pathways, how it absorbs and desorbs. It goes and percolates and goes through. Yeah, that's understanding carbon to nitrogen ratio. Now this is getting into the composting, because if you don't have if your ratios are out, bad things happen. Like if you've got a high carbon to nitrogen ratio, your decomposition will be very, very slow because it's way too high in carbon. And then the minerals will deplete the soil of nitrate and ammonium until they die and release nitrate and ammonium. Microorganisms, will deplete the soil. And if it's too low of a CN ratio, things will happen too fast. So if you've got your nitrogen too high, you want about a 20:1 or a 25:1 ratio. Decomposition is the rapid due to high nitrogen within the plant. So if you've got a very low CN ratio, that means it's going to happen too fast and all the microbes are going to use up everything, and you're not going to get a good end result that you'd like. So that's why that 20:1 ratio to 25:1 is really important. That's briefly touching on it. And these are some carbon to nitrogen ratios of some organic materials. So alfalfa is perfect. It's got a 20:1 already perfect ratio. And microbes, believe it or not, they have an NPK ratio too, like everything does because it's alive. And the microbe population has a carbon to nitrogen ratio of about 10:1. And soil organic matter is 10 or 12:1. It depends, that varies a lot, because if you've got it, if it's too green, that ratio will change a lot. But if you've got an average amount of brown in there, that'll be the average ratio of 10 to 12:1. And maize, corn is 40:1, rice is 100:1. Influence of carbon to nitrogen ratio on nitrogen release. Yes, it controls nitrogen availability to soil and plants. So if the carbon to nitrogen ratio of organic matter is 25:1, the soil microbes will have to scavenge the soil solution to obtain enough nitrogen, making the high carbon to nitrogen ratios, they'll deplete the soils of their native nitrogen, causing plants to suffer from nitrogen deficiency. So it has a big impact on just the nitrogen alone. And you can see here the different ratios and what it approximately does, and how it's the lower the ratio, the faster that decomposition happens. That's actually what that's sort of getting at. Just different examples of different ratios that you can have to speed and slow up the process. So if you were finding that you're having too much green material and your nitrogen is going to be too high and your carbon to nitrogen ratio is too low here, making it decomposition too fast, you can go and add some sawdust as an example, which is very high in carbon. So you look for that really dry, woody sort of carbon stuff, and that's going to alter the ratio heaps just to try and bring it back into check a bit, so you can hold on to your nutrients for your plants. And some basic properties of fertile. No, I don't think we need to go into that. Factors affecting a soil's ability to supply the nutrients. This is kind of, I want to focus on compost if I possibly can. Soil pH, this is always good to speak about. The soil pH's effect on nutrient bioavailability. So if you've got your compost, which generally should be about 6.5 to 7.5, it buffers in the good range. By all of its occurrences, they naturally buffer it into this range, 6.5 to 7.5, making most of the elements available, nutrients available to the plants. But if you're just starting it out, you might want to check your source of inputs, that it's going to not acidify too much and alter your end result too much. So the pH is, extremely important, because if it's not in the correct pH, 6.5 to 7.5, it'll just make, even though there's enough phosphorus there, it will just, the plant won't recognize it because the pH makes it unavailable. We want the H2PO4 minus in medicinal cannabis for the phosphorus. If you're going to look for testing, that's in the first half of the pH range, because the H4, the second half, the secondary, what's it called, ortheno, there's two parts for the phosphorus, because it's pH dependent, and the bit what we want is in this first bit. That's what you want to look for. I'm not going to confuse the situation. Soil acidity, it goes into it too much. Importance of pH on plant nutrition. Yeah, I kind of just explained. It just makes things unavailable. What is this? The soil pH also influences plant growth by the effect of pH on the activity of beneficial microbes. Better nutrient availability found at neutral pH of 6.5 to 7.5. And saline, it's good. It helps in recommendation of soil amendments and fertilizers. Yeah, you want about 6.5 range. So you just got to alter it, buffer it better, even. Inclusive overview to soil plant nutrient relationship. This is a nice big pretty looking chart where it's showing the different processes that happen with the nutrients. So how they react, like arsenic reacts with the groundwater, and it happens through leaching, capillary rise and plant uptake, because most plants are bioavailable. So they'll just absorb whatever's in that area. Look, you've got lead here, chromium sitting there. So it's all can be bioavailable. There it is there. And ion exchange happens through different minerals, depends what's sitting in there. So you've got to be really careful of what goes into your compost. If you've got bad things going in, thinking it's going to break it down, it will. It'll be sitting there, but it might have it locked up into something, but still it has a chance where something might break it down and make it bioavailable or available to the plant. So be real careful what you put into your compost. Nutrient imbalance leads to soil health degradation. That's, over and underuse of fertilizers. Okay, that's finished for that bit. What else? Anyone else is there? Hey, there's GMF. Hello, GMF. Good morning, peeps, he says. I hope you all are safe and very happy outside working in the garden. Yay, you got to be happy too, mate, working in the garden. That's the way. Going through compost. It's International Compost Awareness Week. So I thought I'd go through a bit of compost, and I'm starting with the nutrient cycling before that. So any questions? Welcome to jump in. Oh, here it is there. Look. International Awareness Week. Wow. It's an education initiative of the organic recycling industry. That's why I thought, I've got to support this. Got to support it. All right, next slides. Compost. Here we go. So what is compost? Compost is the decomposition of plant remains and other once living materials to make an earthy, dark, crumbly substance called compost. And it's excellent for adding to houseplants or enriching garden soil. And it should be an element of your substrate. It's, if you see the earthy, dark, crumbly, it's also, you'll know by the smell. And you want the smell to be of an earthy substance, and you'll know it'll just be like a nice, natural, earthy smell. That smell is called geosmin. 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 What is it? So what is compost? Compost improves soil structure, texture, aeration, increases the soil's water holding capacity greatly, especially manure. I love manure, it's amazing for that. Compost loosens clay soils and helps sandy soils retain water. So if you've got a sandy substrate, or even if you dig down and you've got sand down there, you think, far out, I just can't do nothing. You can. You compost or put a lot of organic matter onto it, manures. Start getting cycling. Compost improves soil fertility and stimulates healthy root development. Compost, organic matter, provides food for microbes like in the nitrogen, potassium, and phosphorus mineralized forms. There's a few different methods of composting too. There's probably as small as 7 on this slide they've just suggested. The indoor method's one of the better ones because it's very fast. It happens, it's in 2 to 3 months you can get an end result. Most of these are the ones, and that's an aerobic one too. Some of these are anaerobic, so you can have a chance, if you're not experienced, of developing some pathogens that you don't want. So the indoor, I'll touch on the indoor one. Basically, you just put a pile down and you want to add green to manure. So a lot of these is they mix cow dung in it. There's a fair bit of cow dung involved, and you want to make sure your cows have organic inputs and they haven't got their antibiotics shots of recent within 6 to 8 months at least, because that might be cycling through in their manures, and then you're going to get an antimicrobial resistance built up, which you don't want. You want the opposite. So you mix the manures with green manure, leaves, grass, all sorts of weeds, anything green, and then put another layer on of manure, a few layers on, get it above 1 foot. Don't go more than 2 feet because they reckon you can develop anaerobic parcels inside of 2 feet. So you get it up about 1 feet, and then on top, you get some cow dung and put it with water and slurry it across. And that'll lock in all the nitrogen, so all the ammonium, so that it won't be volatiles back as ammonia back to the atmosphere. And then the first turn is 10 to 15 days, so 2 weeks after you've done that, turn it, slurry it off. Second week, same thing again, another 2 weeks later. And then after 2 months is the third turning. Yes, and then it should be right. That's all I'm going to touch on for that. Methods, no. Vermicompost, here's another form. Composting, it's vermi, and vermi is worm in Latin. So it's composting with worms. And you need the right ones though, because there's it says here, the earthworm species or composting worms most often used are brandling worms or Eisenia foetida, Foetida, or red wigglers. They're Lumbricius rubellus. That's their Latin, their biological names. There's many more you can use. They're just a few, just to mention. There you go, vermis, from the Latin word meaning worm. And they say, that was an exam question, earthworms are the intestines of the earth. And organic materials like humus, cattle dung, and kitchen waste are highly attractive to these species. The cool thing about worms is they secrete ammonia out of the sides of their skin, so you get a little bit of nitrogen bonus. One of my teachers for organic farming, she was a earthworm. That was her specialty. She focused on earthworms in her PhDs or something. What do you do with earthworms? Oh, I'm not going to go through that. What do earthworms do? Oh, what do they do? Sorry. They ingest the solids, they convert it inside of themselves. And one cool thing about them, they can get rid of pathogenic microbes. Is it microbes? Pathogenic, yes. They break them down inside of the earthworm's guts and mix with it and can kill them. So that's pretty cool about the earthworms. Oh, here, massive pathogen-free. Plant and human pathogens are killed during passage of earthworm guts. Sweet, I should just read more, eh? Vermicompost properties. It's just rad. It really is. You'll see the difference after it's broken down too. It forms like little dry looking aggregates, and they're bound together because all the biology, the microbes, they put little biofilm out and that binds things together. So that's why it's all little aggregates. And from that, it can absorb water and have its water holding capacity greatly improved. Like if you get a dry bag compared to a wet bag, wow. It like weighs a ton. It really, truly, it weighs a lot. I did a, here's a different way you can do it. If you want to do your own, just get a little one of those swimming pools, put a few sticks up, bang, you get yourself a little vermicomposting pit. That's it for those ones. And while we're on nutrients, I found this interesting, so I thought I'd share this. I always thought that forests were way more fertile than grasslands. And this is the slide just to show the difference, the opposite. It's quite the opposite, that grasslands have higher amount of soil organic matter than forests. So therefore, they have a higher amount of nutrients availability. So I thought that was interesting. So if you really want to go and source stuff, I thought, oh, I'll just go and grab all this broken down, composty looking material from the, on the top of the floors, the mulch type thing on the forest floors. It turns out that there's, it's quite the opposite. And that's due to the greater amount of plants, the inhibition of nitrogen that preserves the nitrogen and the carbon. So because it inhibits in the nitrogen fixation, it's allowing a lot more nitrogen and carbon to be bound up. And it has a higher humus synthesis and higher base status of grassland soils, which promotes ammonia fixation by lignin. So that's pretty interesting. I'll just see if there's anything going on in chat. Good evening. Hello, Blinky. I have success, Blinky says, with my soil compost and worm mix this last season. Massively strong, healthy bud. See, that's the go. Fair income, it works, doesn't it? And then you get less, you'll find you have less pest problems too, because the plant will be working as it should be working for itself. It's awesome. What's GMF says, don't forget that film that coats whatever passes through the worm's guts is mad for soluble calcium. Oh yeah. That film that coats whatever passes through the worm's guts is made from soluble calcium, he says. Yeah, see, another benefit from worms. They're awesome. So you get compost, and then the compost is a lot of fungus and bacteria breaking things down, and then the addition of vermicastings is the addition of worms. That's the difference in the two. So I'll get back here and share some more stuff and see what's happening. Actually, what was this one? Oh yeah, that was some Du's vermicasting techniques. That's right. That was how to tell the good and the bad. All right, so I'll keep that in mind. We'll go through that after this one. I made a video a while ago on how to do vermicastings and enrich your substrates with different bioavailable materials, biofertilizers as such, and this sort of touches on it. So this is vermicomposting techniques. So you can see here, I made this out of a filing cabinet, and so if you get a old metal filing cabinet and there's say 3 drawers in it, the top 2, you put a tote in them, drill some holes, and put the totes on the angle, and then so the leachate can drain out through the top one into the second one, and then through the second one down into the bottom where you catch it down here, and then you can just put it through and it cycles perfectly. It takes about 2 months for it all to be ready. So I could put it all in, leave it for 2 months, then start working on the next one, and then 2 months later you harvest the top one, and then repeat, and it works really, really well. Continuous flow composting, vertical composting. That's what it is. It's awesome. Here's the 3 types of worms that you want. So there's 3 types of earthworms. There's the epigeic, which are the ones that are on top of the surface and the ones that are really beneficial to organic matter. And then the endogeic, endo means internal, so the endogeic, so they're just internal inside, and they're just nearly as good, but they're a lot bigger. And then the aneic ones are not good. So if you've got massive earthworms, a lot of them, they do vertical tunnels and they eat castings. So you don't want them inside of your, like a way to collect them is to put heaps of material on the ground and watch what comes up, or even flood after the rains. All these tunnels will be flooded and they want water, so they come into the surface. So just don't collect the big anemic ones, the big massive ones. Get the smaller ones if you can. I made a mistake once. I was really excited. I thought, wow, look at these worms outside. I'm going to get some. And then thought later on, I'm sure I got some of these ones. Wikipedia. Oh yeah, this is Wikipedia, and this says what geosmin is. And the human nose is extremely sensitive to geosmin. It is able to detect it at concentrations as low as 5 parts per trillion with a T. So that's the geosmin terpene that you're smelling from good compost. That's what you want anyway. And here's how the worms, they secrete through their pores the ammonia, like our kidneys. It's these, at the side of the earthworms, there's these little dots, and they're called nephridopores, and they secrete ammonia. So if there's no nitrosomus does, it's to do with ammonium nitrosomus. Oh, there's two, because nitrosomus converts ammonium NH4 to nitrite. Then you need nitrobacter to go to nitrate. Yeah. Oh, I just thought there might have been if you got nitrosomus. No, that's wrong. Different microbes do different things. Azos, no, it's not really related to compost. No. Next. Well, oh yeah, that's a good time to explain this stuff. What's the problems if here's like a, what to do if your vermicastings has bad smells or attracts animals, or worms are dying, or worms crawling away, or if there's mold forming, or if it's drying out. So these are all indications and how to remedy them if your vermicasting bin has problems. And the first thing is, the geosmin, that's the smell. So you can work that out every time you throw stuff in. It's got to smell nice. And then if it smells not nice, actually, usually it's aerobic. You've got anaerobic things in there. So that's what's producing that smell. So aerate more, reduce the amount of water, etc. And worms crawling away is big. If you ever see any worms outside of your bin, especially if you do it like indoors or inside of a shed or something like that, if you see them anywhere, that's a massive indication they're not happy. So you have to investigate. You've got to make them happy. Should I go through all of this? I think, how long have we been going for? 42 minutes. Got compost to go through yet. Well, this is just, if you ever get bad smells, yeah, look through this diagram. There's a lot of different things you can do from it. Some solutions might be stop adding feed material for 2 weeks, remove non-compostable, okay, mix in drying bed material to make it a bit drier. Drill holes. There should already be holes in the bottom already to remove your leachate. Otherwise, you will be getting bad smells. If it attracts flies, bury the food completely. Yes, if you've got nice things that you put in, pineapple or anything like that goes on the top, you're going to get a lot of things that are interested in it. So you always have to put something over the top. Some fruit flies, all that sort of stuff are going to come in. Avoid putting rotten food in the bin. Rotten, because it's already attracted some bad things, and you might be harboring bad things if you're not quite sure what to do. But in general, rotting food, well, you have to see how far it's gone. If you're not going to put a carcass in, but if you've got, I don't know, something that's a little bit rotten, I probably would. Remember, good soil, it'll sort itself out. In good soil, there's just as much bad pathogens as good pathogens. Otherwise, to remedy things, if your bin attracts flies, is don't overfeed them. If the worms are dying, Mix in drying bed, leave the lid off, or thoroughly dampen the bedding. If there's mold forming, cut back on citrus or wood. Wood chips, that's really good for substrates for fungus as well. Drying bed out, add water. Righto, that's a good way to do, yes. Collecting in bottom, well, that means you've got to harvest. If everything's already collected in the bottom, you have to remember every couple of months, things just a little sinks. So all of the heavier stuff goes down to the bottom. So when you do a harvest, you'll put it in a big pyramid form, like sprinkle it on top, and then you'll find all the worms will go to the bottom. So you keep scoop off the top, scoop, and then you put some more on the top, and scoop off the top, and then that's a good way to harvest it. Because you have to do it every 3 months in a good cycling, and you'll get a good pail. I couldn't believe how fast it happens. It's really cool. All right, now I think we're on the composting. I might go back and see if there's any cues. No, that's all right. Share screen again. Back to the composting and wrapping it up. Sharing screen, compost. So I think it was this one. Has a few little things to say. Soil fertility is crucial to utmost importance in farming. Yes. So composting is a massive way to add the benefits. It's dynamic, earthy, odorless, granular, humus-rich, and stabilized material. And it's the final product of composting. It's awesome. I like a substrate of 20% compost, 20% vermin, so it's organic compost. I'll put 20%, 20% organic, let's start again. I like organic compost, 20%, 20% worm castings, 10% manure, which I've already sourced from a good source and I've ground up, and it makes it all fluffy, and it's a terrific amendment. It's so good. It's, and then your aeration is the other 50%. That's what I like to use, and I use perlite mostly as aeration. The mechanisms of composting. Yes, so it's heat, release of carbon dioxide, and it's going to transpire, releasing water. So oxygen it needs a lot of oxygen for that to happen. So that's why you don't make your pile more than 2 feet thick. And if you've got any pesticides, any seeds or any problematic microbes that you've had, you want to get it into the thermophilic stage. Right here it is, thermophilic stage. It's where the temperature rises above 65 Celsius, and it's in an active composting process where the heat destroys several pathogens and weeds. Thank you, words. And then after it goes into that for a few days, the curing, where the actinomyces and fungi digest hemicellulose and make it stable. So that's after it'll cool down. They're the 3 stages you want it to go into. Mesophilic is in the normal range where it's below 45 Celsius, and that's the range which we grow in, and we want all of our microbes to be in. So it's a good range to keep it in, so you know that things are going to cycle in that. So this is the reason why you want to get it. Only reason you get it into thermophilic is because the heat, it destroys the pathogens and the weeds and seeds as well. It's really beneficial for that. So you can tell if you just put a few seeds in with your composting process, and then after it comes out, if they end up germinating, you know you didn't get into that thermophilic stage long enough. Especially if you had a temperature gauge. Yeah, it got in there. Well, it mightn't have been in there long enough, or just that temperature gauge around where the probe was. It might have been, the seed might have been over here, and you need to get more of a coverage of your heat. Methods of composting. There's a few Google methods. I prefer the indoor. It's very easy. INDORE, that is. What's all this stuff about? The carbon and nitrogen ratio is important, yeah. Bedding, shredding, manuring, all the stuff you put in, inputs, green manure, gas, slurry. That's probably, I study in India, so they teach you a lot of stuff. So be careful of using slurry because it can have, it's not much oxygen in there, so it can be harboring a lot of bad things. Oil cakes, yeah, that's the process of after extracting them. Liquid farmyard manure. Manure is mad. It's the best stuff. All right, what else is there? That's it. Compost. This is it. Finally got to it after 50 minutes. Finally got to compost. The properties of good quality compost. What is it? How do I know if it's blooming good or not? Well, after it's been harvested, it wants to look browny to black of good quality. And the smell has to be a really, really nice geosmin smell, a nice, pleasant, earthy smell. Not sweet, but you just know it as, wow, that's sort of nice and fresh. And the pH range has to be in that neutral range, and it can go slightly alkaline to about from 6.5 to 8.0 pH. The carbon to nitrogen ratio, you want it that 10 to 20 to range. Now you want 20 to 25 is to 1 is what you'd ideally want. Temperature is 30 to 35 in the mesophilic range. We just sort of covered that bit. And the moisture range is pretty important because it can't be too wet, because otherwise it'll start and harbour bad things, and then you don't want that. So to dry, you want to dry it out if it's too wet, and you want the end product to be about 25 to 30% moisture. So if you were to squeeze it, there'll be no chance you're going to get any drips out. Where if you compost in the process, you want it about 60 to 80%. So when you squeeze it, you want to get a couple of drips out to maintain all that moisture for everything to work as its best. And the humus, you want that in the range of above 4% of good, and that's in good quality. And if it's poor quality, you'll be having a humus range below 4%. The nitrogen ratio, you want that above 1.2% in good quality, and if it's poor quality, it'll be below 1%. So that's where you'll have, if you have a too high, if your carbon to nitrogen ratio is, if it's too favouring nitrogen, you won't have nitrogen in the end because it'll be all of used up too fast. That's why it's important to get that 25 is to 1, 20 or 25 is to 1. Earthworms. Here's just some more examples of the epigeaic ones that you want. Remember, epi means top, geaic means earth. So some other ones are mentioned, the Photida before. Perionyx, excavatus is another biological name of some cool tiger worms. That'll do. Some waste characteristics of compost. So your carbon to nitrogen ratio under 19 will have a lot of animal manure, oilseed residues, fish hydrolyzed, so you can mix that. So that's mostly suitable for a high nitrogen content. So if you want to alter your CN ratios, this is some stuff you can do to alter your ratios to try and get them up good. Vegetable waste, food processing waste, oil seeds, tea bags, kitchen waste, green manures, green kitchen waste, all's in the perfect range. And the sawdusts, so if it's too high, you can add your sawdusts and your wood chips. Not wood chips because they're not really broken down. That's you want to grind them up if anything, and that'll make into the sawdust. If you're putting too much green in, laying out. This is commercial vermicastings. I also did a video on how to do vermicastings. If you've got property, you can do this for free and sell it, and supporting the organic week. This is massive. It's because you can make profit off your own space if you have access to cattle. So you've got access to cattle, you just mix beds up, turn them over at their rates that they turn over, and then harvest them. So sift them out, and then you've got export. Multi-tier ones, I love that one. Look at that, that's out of sticks and stuff, mate. That's tarp, plastic. It's so cool studying where I study, I love it. worm propagations. I went through this a few weeks ago. Still, it just helps a lot. You can pause that if you want, because I'm not going to go through it. This is pretty important. Down the bottom, the propagation cycle in the box or the bed will vary from 50 to 60 days depending on the species season and environmental conditions and what's inside of it. Moisture ratio too. So yeah, a good example of a mixture is green biomass and cow dung, 50% ratio of each. Some vermicastings accelerators. So if you want to get some more saprophytes, which sapro is the decomposition, saprophytic, even cockroaches are saprophytes. Not that I don't like cockroaches, but there's some other ones that you can get that help and accelerate that, like Bacillus polymyxa, Trichoderma viridia. They are ones that will really, if you get some of these microbes, they will multiply, and when put in the conditions, they will produce a lot more of themselves and break it down faster. And then when you're active compost, you want the moisture to be about 60 to 80% with a few drips when you squeeze it, and the temperature to be 20 up to 35. Probably in the higher range if you want it to happen faster. It might happen slower into about around the 20 or the 78 Fahrenheit. You want it up about the, 95 Fahrenheit. Depends on your species too. If you get some Arctic worms, they might like the lower end. Here's the separation at the end. I like to put it on, tip it upside down, make a triangle out of it like that. So I'll tip it upside down, or put scoops onto it, scoop it out. So if I'll tip it, and then all the worms will try and run out. So I'll make it into a pile like that, and they'll all try and go down to the bottom. So I can scoop the stuff off the top, scoop, harvest, scoop, harvest, and then slowly get through, and then I'll sift out towards the end. And these are ways commercially that they do it, through sifting or shaking. That's it. Disadvantage for chemical farming. No, went through that last week. I think that's it for the slides. It is. Let me go through any more. Add to stream. Don't forget the thin film. Oh, yeah. My worms eat. Genetic Memory Farm says, my worms eat mostly organic coffee grounds and filters mixed with cannabis trim and food waste. Yes, the organic coffee is good to put in with your compost. It is an acidic thing, so you can feed like directly to blueberries or strawberries or something that's acidic. But yeah, if you put it through the compost process first, it'll break it down and make it more available. That's pretty cool. And Stony Creek, Stony Creek. R&B harvesting sounds good. Woohoo! Yes, love and laugh. This week is International Compost Awareness Week, so I thought I'd talk about compost and make it a bit aware to everyone, because they're saying that they want, Education Institute of the Organics Recycling Industry. Yeah, so if we can get this word out better, it'll make it a lot more easier for people down the track to recycle, be sustainable, and help their plants from what they eat. It's cool. Yo, great diet there, GMF. Yes, because your plants eat what you give them, and you make up a good substrate and let the microbes really work for themselves and work with the plant's roots to have a good outcome. I hope that came out all right. I think I'm just rambling. Is there any questions on compost or any suggestions on next week's? Actually, I'm going to check that up. Yeah, I'll check that. Chat. And then questions. Oh, yeah. I put in a little Q&A. Any suggestions for next week? So I don't mind any suggestions. Compost all that for at least a month or two, then feed it to the worms. Yeah, that's the go. Then you know the job's done properly. That's the way. Composting is rad. It sure is, mate. nature doing its thing. Well, that's how nature's worked for millennia. And then we've come in the last 200 years, and apparently the human's way now is better. But yet, why is everything going in disarray? Why is 95% of USA's groundwater polluted with pesticides? Why are all these bad things happening? Why is cancers happening in great amounts? So all of this stuff has to be asked. The reason is, it's because we've been lied to. They've told us fallacies like they did with, I'm not going to get into controversy stuff, but so now by knowing all these organic practices, we can just do it as our traditional persons have done it all these years. We can save heaps of money. We can enrichen the soil or our substrates at the same time. There's so much benefits into trying to learn these techniques to give your plants the best. It's not just all about medical cannabis plants. This is in general too. Plants in general, all these techniques that I always talk about, it's not just for medical cannabis. This is really for a lot of plants in general, just their pH range difference. That's about it. So all of these things can be so available to everything. And then people just go and tip their scraps in a bin or something like that, and it could be used. So you have to think of what is in there. Is there many fats or oils, or is there any bad stuff? Should I recycle these? Can I separate my on my plate when I'm eating and possibly recycle it through my compost or through my vermicastings? If you change a few habits, you can really get a lot of goodness out of that. I suppose it's about being more active and just thinking about the ways that you can change habits to get the best out of nutrient availability. Yeah. Vermicompost says Stony Creek. Yes. GMF says it's all about eating well. Cannabis is just another food. Yes, that's right. Whatever we eat, we can go and recycle. It's really cool. Symbiosis. Yes, that's right. Lene. We can get everything working really, really well. And then you can just recycle your substrates and you can get that into your soil food web that you're trying to establish too. And if you go and enrich and all of your with biofertilizers, meaning like azos, Azobacter, Azospirillum, or Bacillus subtilis or Pseudomonas, there's all those different beneficial bacteria that you could use, and fungi, Trichoderma, that are Rhizophagus irregularis. There's many different ones. And then if you go and recycle, you'll be able to keep residues or endospores of those, so then they can come out in conditions down the track. So you're not just throwing all of those money, because they're not cheap for those biofertilizers. They work so well. That's why they charge top dollar. But by recycling, you can do that too and let everything work for you. It's a good way to do it. Like, for instance, what you do, you tip a pot upside down in a tote of water, in a big container of water, and then everything that all the aeration floats, all the roots will sort of float a bit, the root ball, and then all of the soil a lot of it will sink. So you can separate it quite easily. So you scoop off the top, which is all your floaty stuff, to recycle that, which I do, because remember, that might be biochar. There's a lot of available homes in that for your microbes to be stored in. They just love little homes. That's why biochar is so healthy for substrates. So by repurposing your floaty stuff, your aeration, perlite, hydroballs, your wood or bark, or chips, whatever stuff you use, that's going to help down the track as well. That's not really talked about enough too. And then you've got your stuff that sinks, scoop it out, put it into big balls, get the water, store it for 6 months, and then see what happens after 6 months. It's amazing. It's rechanged itself, repurposed itself, and to a good, stable form again. I can't tell you any numbers because I haven't tested it, but from my visual, like on a Munsell's soil chart, it looks fantastic. The soil organic matter is high. It's just really good. So I know that it's done good things, and my nose knows too. It has a really good geosmin smell. So yeah, it's just a few good techniques you can alter to get the best out of your practices, I suppose. It's good stuff. All right, I think I've rambled enough. That's some good information though. If anybody wants to know some more, I'm happy to elaborate more, or I think I've talked enough. So I'll wait a little bit so get some feedback, because we've got the 30-second delay here, and see if there's anything else that's going to come about. But I think that was a really good one today on the compost and organic. What was I saying? International Compost Awareness Week, an education initiative on the organic recycling industry. Yes, it's cool. Very good. Spread the word. Was Genetic Memory Farm says he started 7 or 8 years ago with about 50 gallons of soil, and from recycling his plants and roots into more soil, so I'm well over 250 gallons of ready-to-use soil now. Isn't that fantastic? So 7 to 8 years worth of recycling. So you could imagine all the benefits that he gets. So all those roots, that's another thing I didn't mention too. Thank you, GMF. Yes, your roots should be composted. That's what I put in. So if I'm making up every 2 or 3 months, I'll harvest worm castings. And then so I've got to make up the next one. So the first layer I put down would be all the sticks and twigs. That's, you've got from your sticks and twigs from when you're chopping. And then the next layer on top, I'd put all my root balls. So they go on for a nice, healthy, thick layer, because in them, there's all of the endophytes that are inside of the tissue that have worked symbiotically with the plant. So if you can put them into your substrate and reculture them back up, that's what your plants already love. So you don't really have to re-inoculate with any of these biofertilizers. It's really cool. I made a video on that a while ago on roots, root balls. I don't know, it's in my video list, but there's a video on that on a bit more detail. Inoculating root tea. Yeah, something along those lines. If you want to see in detail on it, it's cool. Yes, he does good work. Great show again, says Dave. I have just been lurking today. I hope everyone's doing well. No worries, Dave. It's all right, mate. I'm sure there's a few other lurkers too. I don't mind, as long as it all helps. That's the main thing, just trying to get the word out on good organic practices so we can all alter our practices a smidgen and ultimately save the planet. That's what the end result is. So it's not polluting things or doing anything bad. And I get a bit of a kick out of doing it. It might take a bit more effort to doing it, but when I'm using my own substrates I've made or different types of cultures that I've brewed up, and then you'll make them into teas, and then you'll enrich those teas. Those types of practices are really rewarding for me. So I'm happy to put the effort in. And you can also go and, that'd be like maybe an all right show. How to get microbes out of your substrates. I have to watch what I YouTube doesn't like a lot of stuff, so I've got to be careful sometimes. But that's interesting if anyway. Oh, American one, how are you going? Nice to see you, Teo. You missed a show today on compost. It's International Compost Awareness Week for the next week, so I thought I would go through it. Here's I'll show you some slides because there's a lot of latecomers today. So I'll show you just some of these funky ones. Like this. This is from Canada. So you should recycle. Just shows the big rhizosphere around here and how beneficial compost is. Right in here, it just does so many good things. It connects us with everything. Builds a good life. And here's the French version. And this is the International Compost Awareness Week from May the 7th to May the 13th. And it's for healthier soil and healthier food and healthier living. Because for our medicinal cannabis, it's just so much more beneficial. Because remember, I was talking last week on the growth balance differential hypothesis that how you get your secondary metabolite profile is enhanced from going organics. That's proven quite a few times. So these practices really, really do pay off. And if you're going to extract, that's next level. So you're going to extract more antioxidants, more anthocyanins, flavonoids, all sorts of rad things in there that are going to really enhance it. So it's it's beneficial. Practices. Yeah. Well, next week I'll be talking as an open topic. So if anyone's got any suggestions or anything like that, they're welcome. Save your questions up for next week, because I don't know what to put up. I'll be relying on you guys and girls for some questions and see how it drives the show. Because I like those ones have been it's just driven in its own way. The people in chat have said this and that, and bang, I start showing slides and talking about it, and then it's driven towards what they want instead of what I want. So I like those types of shows, I suppose. So having the open topics. All right. An hour 10's been going for. Getting on a bit. I released a video this week too on soil. I had one of my exams was for soil science and technology, so I put up one of my stubby sessions for that, and it's just a multiple choice of just, what was it, 15, over 150 different multiple choice questions for a study session in soil science. So if you're interested in soil science and want to get some facts, that's a good little watch you could listen to. I go through and read all the questions out, so you can just listen to it in podcast form. And yeah, about it. Next week I'll be open topicing again. I'll be here, same place, relying on all you nice people in chat. Thank you for keeping it all peaceful. That's what we're about. Plant, soil science, and microbiology. That's what I like to focus on. And the tech side of it. It's so fascinating. You can hear me rambling. Do you got any questions? Yes, great info. As always, Aussie. Thank you, Renee. Very good. Oh, genetic memory farms. I got a topic for next week. Decarbing science, I think that. Decarbing science. Oh, decarbing science. What can I talk about with that bit? That's chemistry. That's one of my lesser stronger subjects, but I do have some stuff on it. Oh, but I couldn't talk long about it, honest. What could I say about that? It's into the secondary metabolites. I haven't talked about secondary metabolites for a while. Always written something else. I am about to do RSO runs and have a few different methods in mind to preserve flavors. Oh, okay. So maybe a secondary metabolite one might be all right then. I suppose I could do all right. I'll title the show then secondary metabolites, and then because decarbing is a topic under it, and then I can see what sort of stuff. I don't have much on it though. But anyway, that's what I can do. That's what you want. Sweet ads. No probs. Is there any other suggestions? Actually, I can pull up some stuff. I can go into some different pathways, how to promote it, how to organically even bring it out. Yeah, there's a few different things that it helps from going organics to your secondary metabolites. Oh, actually, I covered that a few weeks ago. Anyway, what's the American one say? How about discussing also about how THC turns to CBN? I don't think it happens as quickly as people believe. Yes. Okay. All right. And secondary metabolites. We can talk about that. That's an aging process. How THC turns into CBN. It's cool. It takes about, we'll see, I think it's heat dependent, American one, because when you store stuff for a while, you'll find when you get it back, it doesn't give you as much of a high, but makes you more sleepy. That's because the THC is turned into CBN. And after dispensaries, when I used to sell to them in BC, I was working under the ACNPR license when I lived there. They used to say to me that they never wanted, their shelf life was about 3 months. So it could possibly have altered the molecules after 3 months even. But yeah, cool as. We can discuss it heaps more. Good suggestion, friends. American one says, I don't think it ever turns to CBN on the plant, which they say is what amber trichomes are, but I'm not buying that. I agree with you, mate. Yeah, I agree with you because yeah, it does age, and that's what I've heard that too. That's the CBN in the plant, but well, that's pretty fast. It happens. Why is our THCA still really high, but yet our trichomes are amber? Answer that question. So that's why I agree with you, mate. What's he say? I would love to hear what you know about it. Oh yeah, that'd be good. GMF agrees with him. Unbelievable. It is an antioxidant, so it can be denied with environment, I believe. Yes, oxidization. Well, I get, even in cryovac bags, it ages. So that's how I can know that one. And it's all shrunk down massively too. So, yeah. But this is a good topic we can discuss. Rad. What else is said? Yes, that sounds about right. 3 months would cause deterioration or change it. Yes, it has to go from THCA to THC first. Yes, have to make it active. That was that chart that I showed to last week. It was, what was it, 60 Celsius to 120 Celsius was the range of THCA to be decarbed in. Yeah, but I can show, I'll go more into that into detail next week. Good idea, people. Thank you, friends. Thank you very much. So secondary metabolites, at least I can have another heading instead of this up here, open topic. No, it's just straight up secondary metabolites now. Good work, people. Thank you again. And that little, just for those who aren't aware, that little button beneath the money button just helps now and then. So it's just for a bit of support. It's appreciated to all those people that do it. Very good. This goes, I put this out on a podcast now. So this goes, so thank you to the podcast listeners. You're welcome to see me live. It's at AussyCC, one word, on YouTube. Every Saturday in the Southern Hemisphere and Northern Hemisphere. No, in North America, it's Friday afternoons, and everywhere else, it's Saturday. So thank you again. What's some other stuff? Cheers. Going down. Good one. Thanks for your efforts. Good awesome rest of the day. Thank you. Thank you, everybody, for rocking up. Thank you, all the nice chat people. I appreciate it. And all the people that are listening who aren't in chat. Good on you. So I'll see you next week for secondary metabolites. It's going to be interesting. Why do we want them? Why do we need them? Why are they beneficial? Why should we have them so much? What temperatures do they volatile at? How can we change them? What do they manipulate? What benefits do they do to us? What happens if we don't change them and leave them at one form and not the other? These are some of the questions that will be discussed. So I welcome you all next week. Thank you again. Happy breeding, happy growing, and good health to everyone, including the haters. Cheers, everybody. Good night. Good day. Bye-bye.